Hello class, sorry I couldn't be there today. What you're going to need today, you're going to need notes, calculator, property sheets, and what I mean by sheets, you need the formula sheet that I gave you a long time ago, so if you need to make a copy for somebody else, you can do that later. And if you have the property sheets that we made in class where it had all the little flaps for the addition and subtraction formulas for sine, cosine, you could use that as well. But today you'll need your practice semester test. The goals today are to go over two problems from section 7.1. We did two problems yesterday in class. I'm going to review those real quick with you about systems of equations. The reason why I'm bringing this up is because the section we were doing, we have homework due Monday. Keep that in mind. The section that we had on for the homework, which was section 6.6 and 6.7, right? That was vectors. I didn't assign a couple problems that had systems in it, where it wanted you to find the 2 points where vectors intersected, they crossed. So what we're going to do is we're going to do two problems reviewing that. It's something that you need to know for calc. It's like one of the first sections we deal with in calc. And also, it's one of those problems that we've done it in Algebra 2 and we've done it in Algebra 1. It should be very, very easy. I'm going to show you both methods. It doesn't matter which method you like, as long as you know how to do it. But we're going to do two problems with that. I'll walk through those here in a minute. And then once we're done, we're going to go through two problems from your practice semester test. We did 3 yesterday. We did problems... So far up to this point, we've done problems 1 through 8. Actually, we did more than 3 problems yesterday, didn't we? We did, I think we did the entire second page. So we did problems 1 through 8. Goal stage, 2 problems, and then Monday is to finish the practice guide on the back page. So I'm going to keep it pretty easy today. I just want to make sure we go through these, that you have all the notes. Again, at any point, you can always pause the video. You can rewind it if you need to catch something again. I posted this to my website, mrward.org, so you can go back and watch these on your own. So if you have headphones, you can go watch it. Hopefully, it'll be clear enough that you can understand what I'm going through here. But just make sure you have everything out ready to go. I'm going to start, and we're going to kind of cruise through this here. All right, so we'll start with the two examples from section 7.1. So as I'm listing here, there's two methods of solving a system, right, where lines intersect. There's an elimination method, and then there's a substitution method. We're going to do an example of each type. So I'm going to start with the elimination method first. So let me mark that here. So we're going to do this first method here. And what I'd like you to do is we're going to draw a line underneath these two equations. This is my equation I'm going to use here. So somehow they're intersecting. Now, again, these don't have to be intersecting at any pretty point. These could be crazy decimals. But what I want to do is to walk through how to solve this if you didn't know where they're crossing. Because obviously we haven't even drawn this yet. We haven't graphed these. So we're going to do it by hand and kind of see where these are going to actually meet. So you have to pick one of the variables. It doesn't matter which variable you pick. You want to pick x or y. I would probably recommend the easier one, which in this case would be probably the letter y. It works either way if you pick x or y, but I'm going to pick the y's. The reason being is that the numbers that are in front of the y's, it's a 1 and a 2, and one of them is already negative, which is nice. So it saves you like a little bit of steps. So I'm going to pick the y's here. Let me mark those. So these are the two that I'm going to be picking. So what I'm going to need to do is I need to make both y's the same number, and I'm going to keep the bottom one the negative. So what I'm going to have to do here is I'm going to multiply the bottom row by 2. That way it makes the y's both 2's. So the top row is not going to change. In fact, I'm going to just rewrite the bottom or the top row. That's 4x plus 2y equals 12. The bottom row, by distributing the 2 throughout the entire row, I get 6x minus 2y equals a negative 2. So that's multiplying a 2 onto every single number on the bottom row. And notice I didn't use a negative because the y is already opposites. I don't need to throw in a negative sign in there, which is kind of nice. That's why it kind of helps to know which one to pick. Now that we have that, if you have your variables the same number, which they are, they're both 2's and they're both opposites, now you can just add straight down. So 4 plus 6 is 10x. I'm having issues with drawing that. X. Why I won't draw an x anymore? That's odd. There we go. Weird. Okay. So 10x. The y should go away, and then 12 and a negative 2 make 10. All right, I don't like the x. Let's erase that and start over with that. It just really does not want me to draw the x. That is so weird. Okay, just didn't want me to put it in that one spot, I guess. And then you're going to divide this 10 across. So x is equal to 10 divided by 10, which is 1. You probably already figured that out minutes ago, which is 1. Now, once you have that, you need to take that 1 and plug it back in. Now, the recommendation I always have is always plug it back into the top equation. It really doesn't even matter. I always just say take the top one. So 4x plus 2y equals the 12. And I'm going to take the 1 that we just found, and I'm going to plug it back into the x, because that's the variable that it stands for. So 4 times 1 plus 2y equals 12. This is 4 plus 2y equals 12. Subtract this across, so you get 2y is equal to 8, because again that's 12 minus 4, and then divided by 2, and you get 4. So there is your two variables. So you have a 1 and you have a 4. That's the intersection point. So if you're writing the coordinate where they're actually crossing, it's 1 comma 4. In component form for vectors, that would be whatever the vector's name is, w vector, equals 1i plus 4j, because you can just see the intersection points. But again, we can fill that in Monday if you want to know why we're doing this stuff. All right, let's move on to the second type of problem, which is substitution method. Now, why I would ever pick the substitution method is because it's when they already start where one of the variables is already solved, right? So like if you're looking at that second equation on this problem, they already have the x by itself. So what you can do there is, knowing that that x is by itself, you can immediately take the part that x is equal to and plug it back into the top equation, like the other equation. So I'm going to go up to the top equation, and I'm going to take out the letter x, the variable there. And what I'm going to do is I'm going to substitute what x is from the bottom equation. That's the 2y minus 8. Now that I have that, I can distribute over that parenthesis. So I can distribute the 6. So that's 12y minus 48 plus 1y equals 17. And again, you don't need the 1, but I just threw that in there. And then we're going to combine like terms. So this is 13y's. We have the minus 48 equals 17. And now what we're going to do is we're going to add that. We're going to add this 48 to the other side. So 13y equals the 17 plus 48. And you guys are already laughing because you know I can't add in my head. 17 plus 48, 65 equals 13y. And then we'd have to divide by 13. So let's go back to that. So divide by 13, divide by 13. Again, 65 divided by 13, 5. Now, again, just like the last problem, whatever we have here, you would take that 5 and plug it back into the original equation. So I would take and I always go to that second equation, this one right here, plug the 5 back in because you know what letter it should go into. It should go into the y. So 2 times the 5 minus 8. And again, that's the second equation, plugging that 5 back into the y variable. So that's 10 minus 8, which is 2. All right. Hopefully that made sense to you for both systems. Again, it really didn't even matter the method you used. You could have actually done the elimination method on this problem because you could have moved the 2y over and just stacked the two equations again like we did the last problem. But it's just one of those go-to versions that it doesn't matter which form you use, like which method. They'll get you to the same results anyway. It's just sometimes people prefer substitution because it's all algebra 1. Some people prefer the elimination method because it takes less steps, but it requires more higher level thinking. But those are the two methods. And again, one of these is on the semester test, one of the methods. It doesn't matter which method you pick, but one of the problems is on the semester test because it's something you need to know before calculus. So just kind of be prepared for that. I know some of you were gone yesterday, so definitely watch this video a couple times to get used to that. If you need help, come in Monday. I'll be here again. But let's move on to your practice semester test. So you can put your notes away for right now, take out your property sheet and the practice semester test. And we're going to jump right in. We only have 2 problems to go through today. We have problems number 9 and 10. All right. Now, number 9, sorry, it probably looks different on your practice guide, but what we're going to try to do is we're going to try to find a very specific thing on this picture. We're going to try to find the distance from A to B. So if you read the actual story problem, they have some weird story with it. But we're going to try to find that distance right there. The distance from A to B. Well, the first step is on this particular problem, number 9, we're going to have to use the law of sine. Now, how I know that? We have all the angles in the picture, and we even have one of the walls. Well, I know we have every angle of this triangle is because triangles have to add up to be 180. So you can take, and you could take 180 and you could subtract the 62 and subtract the 53, and you'd get 65 for this bottom angle. Again, triangles have to add up to 180. It's one of the basic properties about triangles. So taking and subtracting the other two from 180, you'd get the 65. Now you can do the law of sine, and you could set this up where how this works, you go sine of the angle over its opposite wall, which would be the 300 yards. I'll label that. And you can set that fraction equal to the other ones. And again, you have to use the sine, right? You can't just set it up as a proportion like 65 over 300. It doesn't work that way. So sine of 65, the angle, over its opposite wall. And since we're trying to find x there, we're going to go sine of 53 over x. And again, why you're doing that is because when you do the law of sine, you have to use the angle and its opposite wall. And this is the wall we're obviously trying to find, the distance from A to B. So when you solve this problem, we're going to have to cross multiply and divide. So I always tell you, I call it fish method, it's cross product. But you start with the number above or below x, you cross multiply diagonally, and then you divide by the last number, and it looks like a goldfish. Right? There's your goldfish. Nice and pretty. All right. Now, again, if you're typing that in your calculator, I'm typing 300 times the sine of 53. I would actually probably hit enter on a calculator just to figure out what that number is. But then you divide by the sine of 65. Now, again, why I would probably hit enter after you do the top is because some calculators require like a ton of parentheses, like my own calculator does. So you have to be very specific where you close things. So I would just figure out what the top number is first and then divide by the bottom number. But again, if I'm actually going to type this in here, so 300 times the sine of 53, and then whatever that is, I'm going to divide that by the sine of 65. And it looks like I'm getting 264.36, and that's in yards. Again, go 2 decimal places. I know it says tenth, but just 2 decimal places in case you're off. If your calculator isn't giving you 264, it could be a potential thing where maybe your parentheses aren't closed, so it thinks you're supposed to be doing other math than you are. But it also could be you're in the wrong mode. Maybe you're in radian mode, not degree mode, so it's not typing in the right numbers anyway. Again, I'll be back Monday. If you're using one of my calculators, great, fine. Just make sure you're practicing this at least once before moving on to make sure you know how to get to 64. All right. Let's move on. Let's go to problem number 10 here. Hopefully that made sense. Again, you can always pause the video, rewind, whatever you need to do. All right, number 10. Last problem of the day. We're going to be finding the distance from A to C across the lake. This problem requires the law of cosine. So again, I'm warning you right now that on the semester test, you're going to have 2 problems, 9 and 10, where one's a law of sine, one's a law of cosine problem, like this. They could be directional bearing problems where you have to fill in your own numbers in the pictures. They could be problems like this where it's kind of all the numbers are given to you and you're just trying to find the one wall. Just be prepared. It's a problem that you've seen in the past. You've done it on homework. You've done it on either practice tests or tests before. So it's a problem you definitely have done before. I'm not going to make up some new one that's super difficult. So again, the goal here is we're going to find this x. So to do this, we have to do the law of cosine. How I know that? You have the angle and you have the 2 walls that are around it. You don't have opposites anywhere. So we can't do the law of sine on this one first. So how this works, the law of cosine is x squared, the wall you're trying to find squared, the wall across from the angle, is equal to the other 2 walls squared add together. So it kind of looks like Pythagorean theorem, even though this is not a right triangle. So you can't just stop there, right? It's not a right triangle. So what we have to do is we add this little extra piece where you subtract 2 times the 2 walls, cosine the angle in between them. And what this little extra piece is, this compensates for not being a right triangle and trying to do the Pythagorean theorem. A squared plus b squared equals c squared. But this should work. Now, doing these numbers, they're insanely big, but in the very end, we have to take the square root anyway because we have a power of 2 here. So that's why it's going to bring all these numbers back to something smaller. So again, typing these in, 140 squared, that's like 196,000 or something like that. 140 squared. 19,600. And then the 16 squared, 160 squared, that's 256 with 2 zeros, so 25,600 minus. And now in the back, we're going 2 times 140 times 160, which is 44,800 cosine. What is that, 80? All right. Now, this is the part that most people mess up. It's this next step, right? Because all I'm doing is, doing all the numbers, the basic operations here. The part that people mess up is that they try to subtract and add these three numbers together. You cannot do that. The reason why you can't do that is because this part back here is being multiplied together, and you have to do that math first. You have to multiply those two things together. So, in fact, I'm going to type that in my calculator right now. The 44,800 times the cosine of 80. And I'm getting 7,779.44 if I round. Again, that's about as close as I need to get for right now. We're approximating this. And now I can add these numbers straight across, because I had to figure out that math first. Because if you think about an order of operations, you have to multiply and divide before you add and subtract. So 7,779.44 plus the 25,600. Oh, actually, no, I got to subtract, don't I? Ooh, hold on, I just made a huge mistake. 19,600 plus 25,600, and then subtract the 7,779.44, and we get 37,420.56. And the last step here is to take the square root of this. Because again, to get rid of a power of 2, you have to do the inverse operation, which is a square root. And square roots are inverses of each other. So the square root of that. So again, this is something you should practice on your calculator to make sure you know how to take square roots, especially if you're using a new calculator today. You should be getting 193.44. And that should make sense. The numbers aren't very big. I shouldn't be getting thousands or anything, because the other two numbers for this picture were 160 and 140. So it had to be in that same ballpark. So 193 made sense. Now, what that also tells me on this picture is that angle A and angle C have to be smaller than 80, because the bigger angle gives you the bigger wall. So 80 is the biggest angle of that triangle. So it's definitely an acute triangle, even though the picture doesn't look like it, but it's supposed to be an acute. And so we could potentially find the other angles if we do the law of sine, but you don't have to on this one. All right. Hopefully all that made sense to you. You can go back and watch the video, pause, go back. These formulas, the law of sine, law of cosine, are on your property sheet if you have it. It's on the side with the unit circle, the big circle. You can see them, they're off to the side. So hopefully you know how to do that. Be prepared. Monday we're going to do the next few problems in your practice guide, the back page, and then we're done. We're ready to go for Tuesday. Book check-ins are Monday, so make sure you have your textbook. I'm checking those in. I'm going to collect those from you. Any problems you have today, I'll gladly go over them again on Monday, but we need to get prepared. Semester test is Tuesday, Wednesday next week. Late work is due today. Keep that in mind, and have a great weekend. Goodbye.